Practice test 1, part 8. Let's finish off the last two questions. Question 15, use the full truth table method to test whether A logically implies B. Show your work and be explicit in your answer. Question appears as so. Okay, so I've got the two formulas here, A and B. All you do is compute the truth values. I'll have to do not P first, right? So it's false, false, true, true, negation of P. False antecedent suffices for a true conditional, right? Now here we've got what? T hook T, that's true, and T hook F, right? Q is F here, so this is false. That's the major operator, A, so it's T, 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 F, and P or Q you know as T, 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 F, right? So yes, the answer to the actual question is yes, right? That is A does logically imply B. Why is that so? Because you don't have any instances of A being true and B being false. Remember, logical implication is the harder of the concept. Logical equivalence is the easier of those two. Those are the two concepts, logical implication, logical equivalence. They're the two concepts which apply to pairs of statement forms, okay? Logical equivalence is easy, it's just they're equivalent. The two columns under the major operators are identical, right? Logical implication is harder. Logical implication is when you don't have a true going to a false, you do have logical implication. And it's true that you don't have any T's going to F's. Here are the three T's, and they all go to T's. All the T's go to T's, so there's no T's go to F's. All right. So that's the answer to the question. The answer is yes, A does logically imply B. It is also true that A and B are logically equivalent, and it's also true that when two formulas are logically equivalent, each logically implies the other. So it's also true again that B logically implies A. Okay, question 16. Use the full truth table method to determine if the following set is consistent. So I've sort of done a shortcut on the board. You should do it differently on your exam. But, so notice these formulas here, 16. A and D have just one sentential variable, although B and C have two sentential variables, P and Q, right? How do we work this out? Well, you have to determine if the following set is consistent, so you have to do a joint truth table, right? So you have to use the same base columns for the joint truth table, because you need to know if these formulas all come out true with the same in some row. That is, what is a row? A row is an assignment of truth values to the sentential variables, right? So a row is, for example, when P is true and Q is false. That defines a row, as it were. Think about what the short truth table method was, where we tried to hone in on a counterexample by assigning truth values to the formulas and then finding our way back to the truth values of the sentential variables, such that to try and make a counterexample possible. Right? We'll try to find or produce in the short truth table method, but there were lots of variables, like 6 or 7, try to find an assignment of truth values which makes the premises true and the conclusion false, right? That is equivalent to a row in the full truth table. But we use the short truth table method when it was impractical to do a full truth table, which is so if there's 5 or 6 variables, because you'd have too many rows. But here, so what you would do, you'd say, okay, the formulas A, B, C, D, the formulas B and C, those are the ones that have the most sentential variables. They've got P and Q, so we're going to need 4 rows, right? So we're going to have the same rows again. So you would actually write these again along with these 4 formulas, right? So I've sort of cheated in that I've taken them over from the last question. Don't do that. You write P and Q, have the same true things, then compute these. All right? Just doing that too. It's speed things along. All right. So when you'll compute, you might be, wait, what? Why do I have to have P and Q when I'm calculating Q hook, not Q? You just ignore the truth value of P. You're just looking at the truth value of Q, right? So Q is true, false, true, false. So I've got to calculate not Q first, so it's false, true, right? What is Q? It's true, false, right? T hook F is F, false hook, true is true, T hook F is false, antecedent suffices for a true conditional. So that's my truth table for the first one, false, true. All right, we got B. Okay, I'm going to do it 1, 2, 3. 1, this column, 2, this column, 3, this column. Okay? Remember what you're looking for here in the end. This is a test for consistency. What's consistency? Most of the truth table concept, I think, is columns, right? Tautology, contradiction, is columns. Consistency is the row one. Consistency is if there is one row in the joint truth table where they all come out true, yes, they are consistent. If there does not exist a row in the joint truth table where they all come out true, it is not. Then this set of formulas is not consistent. Notice this is a set. You've got 4 formulas. Notice you don't have a conclusion. The difference between 12 and 16, 12 has the 2 premises and the therefore sign next to the conclusion. So that's testing an argument form. Form is a form of an argument is a set of statement forms separated into premises and conclusion. That's what's lacking for 16. You've got a set of formulas, a set of statement forms, not separated into premises and conclusion. No one of them is the conclusion. All right, so let's just do it. Not P is false, true. Q is true, false. So true, false or true? False or false is
which one?
False, true. Is it false? This is true. False, true. Okay, so that's true. So I'm looking at this one, I'm negating this, I'm negating T, F, T, T. So it's F, T, F, F, right? That's my column, right? This is the only one I look at when I'm becoming a terminator to look for T, 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 right? I'm going to be looking for a row to match this, like terminator. Match, if I get a T, 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 it will be consistent. If there's no such one, it will be inconsistent. But I've got to be, there's a whole, with this just this formula, there's a whole bunch of T's and F's all over the place. I've got to be looking at the right one. For this one, I'm just looking at this. So actually, it turns out the only possible row is this one. That's the only one where that's true. So far, so good. All right, P by conditional Q is TFFT. That's the problem. You can't even see the. You should know that. Those base columns. TFFT. Not P is just false, true. False, true. Do fill them out if you're asked to do a full truth table method. Okay, and then we just inspect. Now we become the terminator, right? It turns out, as I said, if you just look at B, whenever you see a false in any column under the major operator, that rules out that row because we're testing for consistency. They have to all be true, right? So just looking at B, as we said, it can only be row 2. This is true here, but in that same row, these two are false, so these formulas are not consistent. And that's what you say, just explain in words. There is no row where they all come out true, so it is an inconsistent set, not a consistent set. All right, that's it.